Hello everyone. So welcome to the lecture 2 of engineering thermodynamics. So we'll be discussing more on system today. We have discussed little bit yesterday. So as you know, wherever our focus is called the system, or in the region of space where we are focusing or we are giving the attention, and anything external to the system is the surrounding. And what we can say is, so your universe is equal to the system plus surrounding. Okay, and the line which divides the system and the surrounding is called this one. As you can see, right, I am showing it, the red one is the boundary. Okay, all right. So our boundary can be a real one or it can be an imaginary one. Let me explain this to you. Okay, suppose this is our nozzle. We will be discussing many thermodynamic applications like nozzle, pumps and refrigerators and compressors in our upcoming videos. So let's say this is our compressor, our nozzle. Okay, so let us show you with some dotted lines. This is the system where we will be focusing, right? So the dotted line shows this is our system. Okay, so here this and this boundary are the real ones, and where there is no real boundary, where we are only showing with the dotted lines, right? So this one are imaginary boundaries. Okay, all right. So boundary can be real and imaginary, and your boundaries can also be rigid, and boundaries can be rigid, fixed or movable. Okay, let me explain this to you. Let's say this is your piston cylinder arrangement. Okay, this is your cylinder, and this is your piston. Okay, so as the piston goes up and down, so this boundary with the piston is your movable boundary, and these three sides that I am showing you, the green ones of the cylinder, are the fixed ones. I hope you are getting the point. So fixed ones, and so the fixed ones are the boundary that are shown by the cylinder, and the boundary that is being constructed by the piston is the movable one. Okay, so your boundary can be fixed or movable, or it can be a real one or it can be imaginary one. Okay, so boundary is what that separates the system with the surrounding. And what is surrounding? Anything external to system. All right, anything external to system is surrounding. Okay, and more on system can be of three types, as I have discussed yesterday a little bit. Like the first one is our closed system. Okay, and the second one is open system, and third one is the isolated system. All right. Okay, let's come first to a closed system. All right. Closed systems, let's suppose this is our closed system. In closed system, there is an energy in and energy out, but that is energy transfer is possible, but mass transfer is not possible. Whatever the mass is there, it will stay inside that container. Let's say your piston cylinder arrangement without valve. Piston cylinder arrangement without valve. Here the mass of the gas remains constant, okay, or fixed, you can say, but the heat can go out and in. The heat can go out or go in, okay. It can go out and in. Heat is a form of energy, as you know. So in closed system, the mass transfer is not possible, but energy transfer is possible. Okay, that is a case of cylinder piston arrangement without valves. Okay, so this is your closed system. Next is your open system. Supposedly you have a piston cylinder arrangement and there is an inlet valve and there is an outlet valve, and here is your piston. So the gas can make an entry and then an exhaust gas in the form of mass will go out. So there is a mass out and mass in, and also there is a energy in and energy out. So if this is a system, so there is energy in, energy out. Also there is mass in and mass out in open system. And here the example will be cylinder piston with valves. So these are the valves, okay, where the fresh inlet gas is coming through the inlet valve and the exhaust gas is coming out of the outlet valve, okay. And your last one is the isolated system. Okay, here energy transfer is not possible and also mass transfer is not possible. So there is no change in energy, no change in mass, and also since there is no exchange of anything, your Q is equal to 0, that is change in heat. We will be discussing this thing in our upcoming videos. You can now consider it on these 2 points. So here example is our universe, or hot tea, or you can say ice in a thermoflux. Ideally thermal flux or thermoflux, okay. Ideally it is isolated system, but as we know it cannot keep the hot tea as hot for infinite time. But ideally is an isolated system where there is no energy transfer and mass transfer, okay. And more on this thing, there is another 2 topic that will be coming in, we'll be discussing in the next video, is the control volume and control mass. It is related with the open system and closed system only, but we will be not discussing in this video. So if you are up till here now, thank you very much for watching this lecture 2 of engineering thermodynamics series. We'll be coming with the 3rd video, starting with control volume and control mass with microscopic approach, also with the properties of system. Thank you so much for watching.